Good day, everyone. Today we're going to be solving questions from topic-based trial exam number 2, published in 2024 on the following topics. Let's consider the very first question, and it says, in a car park, there are 18 vehicles consisting of buses and taxis. Each taxi requires 4 new tires, while each bus requires 6 new tires for a total of 94 tires. How many taxis are there in the car park? I'm going to create a little table that will help me to solve the problem. So I can see that we have 18 vehicles in total, and we have 94 tires in total. So we have number of vehicles made of buses and taxis. And we have also number of vehicles. And we also have number of tires given. Total number of tires, I must say. So let's add one more column for the total number of tires and vehicles. It's easier to fill in those, parts right away. So we have 18 and we have 94 tires. Well, I don't know how many buses and taxis in the car park we have, so we're going to be using some variables, hello algebra, to represent their number. So let's say we have X buses and Y taxis, X, Y. Everything represents the quantity, their number. Well, since each taxi needs 4 new tires, as it's written here, and each bus needs 6 new tires, number of tires for X number of buses would be 6X, and number of number of tires for Y taxis would be 4Y. And that's it. Once we have this information, once we have this table written, we can, just write this information in a more concise, compact form. So X plus Y would ends up being equal to 18, and 6X plus 4Y equals 94. That is it. Now we have to solve this problem, and we need to particularly find the number of taxis, which is basically Y. This is what we have to find. To find number of taxis or Y, I'm going to multiply. First I'm going to divide everything in the second equation by 2 because I don't want to deal with, large numbers. So if to divide both sides of the second equation by 2, we're going to have 3x plus 2y equals 40, 7, isn't it? Once we have it, I'm going to use one of the methods to solve a system of equations. I'm going to multiply both sides of the first equation by, to find y, I'm going to multiply it by -3. I want to get rid of x's in both equations. I'm going to use elimination method. So I'm going to multiply by -3 every part of it. So it's going to be -54. So 3x plus 2y equals 47. If to add up both equations, we're going to end up on having -y and -54 plus 47. So y would be equal to -y equals -7. Oh, I have no space here, so I'm going to move here. -y is equal to -7, or y is equal to 7. So we have 7 taxis in the car park. Question number 2. You bought pens and notebooks totaling 24 items. Each notebook costs 50 coins and each pen costs 30 coins. With a total expenditure of 11 manads, how many notebooks did he buy? Well, I just read the problem and I don't remember much of it already. So it means that I need to create yet another table that will help me to organize the given data. So what I see here, we have totaling number of items. So we have 24 items in total. So I'm going to use this information. So number of items, this is what is given. And then we have final total expenditure. I'm gonna add it another row here for expenditure. And we have number of items consisting of pens and notebooks. And we have their total number given, easy to fill in. So we have 24 items consisting of pens and notebooks. Since number of pens and notebooks is not given, I'm going to be using again variables. Let's say we have X pens and Y notebooks. Then expenditure, we spend on everything 11 manat, so 1100 coins. And since each each pen costs 30 coins, X pen will cost 30 times X coins. If we have Y number of notebooks, and if each notebook costs 50 coins, it's going to be 50 Y coins, the expenditure on notebooks only. That's it. Once we have this table fully filled with information, we can, switch or write down something in more concise form based off the table. So we have X plus Y totaling 24. And we also have 30X plus 50Y. That's equal to 1100. That's it. What we have to find, how many notebooks did he buy? Notebooks, again, we have to find Y from this system of equations. So what I'm going to do, I see again, I can divide both sides of the second equation by 10. I don't want to deal with large numbers. So I'm going to rewrite the first equation as it is. So we have 5x plus y equals 24, and I have 3x plus 5y equals 110. So since I have to find number of notebooks, or in other words, y, I'm going to multiply the first equation, or both sides of the first equation by -3, just to get rid of x in the process of, solving this system of equations using elimination method. So I'm going to have -3x minus -3y equals negative, what is that, 1272. Then we have 3x plus 5y equals 110. So using elimination method or adding both equations, we're going to have on the left hand side 2y. Oh, I have no space again, so let's move on here. So I'm going to have 2y, and what we're going to have, 110 minus 72. So it's going to be 8, and it's going to be 38. So y would be equal to 19. So yes, we have 19 notebooks. That would be question number 2. Let's move on to the question number 3. Find a plus b from the system of equations. Again, there are different methods that we can use to find, say, substitution method to find a and b, or elimination method, so to find a and b separately. But if they gave you, the question where you have to find a plus b as a sum already. So maybe, just maybe, you can find it right away. And what I see here, if to add left-hand sides and right-hand sides separately, we're going to have something interesting. So what we have here, a plus 3b plus b plus 3a would end up being equal to 4a plus 4b on the left-hand side. On the right-hand side, we have 20. And now I see here that I can divide both sides by 4 of this equation. So it's going to be a plus b being equal to 5. And that's it. So really, we don't need to find a and b separately. Question number 4. Two containers contain salt solutions. The first container holds 50 liters of a 20% salt solution. So let's visualize the given information right away. So we have first container that holds 50 liters of 20% salt solution. So we have information about the amount of the solution. We have also information about the percentage or concentration of the salt in that solution. Given these two information, we can already find the amount of salt in the first container, which is basically 20% of 50, and it's going to be equal to 10, isn't it? How we can find 20% of 50? 50 times 20 over 100, so it's going to be indeed 10, or we can use proportion. So if the whole solution, which is 50%, 50 liters, is 100%, so what would be its 20% x? And since it's direct proportion, we can use cross multiplication, and the final answer is indeed would be 10 liters again. Now, so we have this first container that holds 50% salt solution, while the second container holds a 50% salt solution. So we have no information about the whole amount of the solution in the second container. So we're going to name it as, well, already occupied x here. So I'm going to use different variable. I'm going to use, say we have y liters of the second solution, the concentration of which is 50%. And again, given these two columns for the second container, the amount of solution and concentration, it's easy to find the amount of salt in that solution, which is basically 50% of y. In other words, it's going to be 0.5 times y. And when we mix these two solutions together, when the two contents of the two containers are mixed, the resulting solution has a salt concentration of 35. How many liters of the solution are in the second container? So we're mixing first and a second containers. So in the first container, we have 50 liters of the solution. In the second container, we have y liters. So in total, we have 50 plus y liters of the solution. Well, you can't really see the concentration of the mixed solution with the naked eye. So you can't really say that it's going to be 70. Well, in this particular problem, the concentration is given, and it's equal to 35%. And the amount of salt in the mixed solution would be 10 plus 0.5 y liters. So basically, 35% of 5 plus y. So basically, it says 35% of 50 plus y equals 10 plus 0.5 y. So now I have to just write it in more mathematical way, so without this, words and etc. So it's going to be 50 plus y, so 35% of, I'm going to multiply 35 over 100 times 50 plus y equals 10 plus 0.5 y. And now I have to solve this equation. I see denominator being equal to 100. Let's multiply both sides by 100 just to get rid of the fractions. We don't like fractions and working with them. So let's see, it's gonna be 35 times 50, 1750 plus 35y equals 100 times 10,000. Oops, so what do we have here? Plus 100 times 0.5y would be 50y. And that's it. Next, we can subtract 35y from both sides. We're going to have 15y left on the right-hand side. And we can subtract 1,000 from both sides. So we're going to have 750 on the right-hand side. So y would be equal to, what is that, 50. And this is what was asked, what we had to find. How many liters of the solution are in the second container, which is basically we had to find y, and y is equal to 50 liters. At what value of the constant c, system of equations has infinitely many solutions, and the second, this system of equations has a unique solution. Well, for a system of equations to have, particularly if equations are given in the general form, these two linear equations, as we can see, are given in general form, ratio of all coefficients must be the same. So basically a over 4 that is equal to 3 over b must be equal to 10 over 20. Graphically, you can think about these two linear equations coinciding or overlapping. So let's say this is the first equation, and L2 would be the second equation, and graph of L2 would be right on the graph L1. So they are overlapping. So basically their slopes and y-intercepts are the same. Well, given this ratios, we can find, well, given the first ratio and the third ratio, we can find the value of a. So basically, if we're gonna equate a over 4 to the third ratio, 10 over 20, we're gonna have a that is equal to 4 times 10 over 20, or 2. Then, if we're gonna use second ratio and the third ratio, 3 over b that is equal to 10 over 20, we're going to find the value of b, which in this case 3 over 20 divided by 10 would be equal to 6. Now, we are done with the first part of the question. We found a and b. Now, we have information, we have to find the value of c for which this equation has a unique solution. So if to think about this question graphically, so these equations basically should intersect at a single point. So basically their slopes are different. So what we're gonna write here, a over 5 doesn't equal to b over c. And a and b already have been found, so we can substitute 2 instead of a and 6 instead of b to find the value of c. So c doesn't equal to 5 times 6 over 2, doesn't equal to 15. How you can understand the given answer? So some of you ask me if this question is not correct. So should it be equal to 15? No, the question is correct, and the correct answer is indeed a, that is c doesn't equal to 15. So how to understand? So basically, for all values except 15, for all values of c except 15, the system of equations has a unique solution. So basically has one solution. Next question. Question number 6. A river flows at a speed of 3 kilometers per hour. A boat traveling downstream covers a certain distance in a half the time it would take to travel the same distance upstream. What is the speed of the boat in still water? So again, let's visualize the information by using a table that will have information about the speed, the travel distance, and the time spent on this distance. So we have information about boat traveling downstream and upstream, and we have to find the speed of the boat in still water. So first thing, you have to understand that the speed of the boat would be equal in this particular questions, in this type of questions, to the speed of the boat in still water, or it would be equal to the speed of the boat on the lake. So basically where we don't have a current. So they might ask you the same thing in different ways. In this particular case, they ask you the speed of the boat in still water. They could have asked you just to find speed of the boat. So speed of the boat traveling downstream would be speed of the boat plus the current, or the speed of the flow. In this case, it would be 3. When you're traveling upstream, it's going to be speed of the boat minus speed of the current, because you go against the river. Okay, when it comes to the time it takes, a boat traveling downstream covers a certain distance in half the time it would take to travel the same distance upstream. So if you travel downstream for t hours, you're going to travel upstream for 2t hours. The same distance. So let's say you cover distance that is equal to s, because it's the same distance. So s would be equal to v times t, or speed of the boat plus 3 times the time. On the other hand, s is equal to speed of the boat minus 3 times 2t. We see that the left-hand sides are equal, so we can equate the right-hand sides. Speed of the boat plus 3 times t equals speed of the boat minus 3 times 2t. Okay, let's simplify. Let's get rid of t's on both sides of the equation. So we're going to have speed of the boat plus 3 to speed of the boat minus 6. What we're going to have, speed of the boat is equal to 9, or speed of the boat in still water is equal to 9. Next question. A boat travels downstream at a speed of 20 kilometers per hour and upstream at a speed of 20 kilometers per hour. So let's so what we have, speed of the boat traveling downstream, it's basically speed of the boat downstream plus speed of the current, and it's equal to 20. Then we have speed of the boat traveling upstream. It's going to be speed of the boat minus speed of the current, and it's equal to 12 kilometers per hour. If the distance traveled downstream and upstream is the same, how many times greater is the boat's speed in still water compared to the speed of the river's current? So how many times speed of the boat in still water, or just, in other words, speed of the boat, is greater than speed of the current? So basically you have to find this ratio. Well, what we have information about speed of the boat traveling downstream and upstream. We can use this little system of equations here. I can add both equations and have 2 speed of the boat equals 32. So speed of the boat would be equal to 16. So if speed of the boat is 16, speed of the current, so you can plug in 16 in either of these equations, and it's going to be equal to 4, as you can see. So speed of the current is 4, speed of the boat, or just speed of the boat in still water, would be equal to is 16. So the final answer is 4 for this question. Solve the equation, the system of equations. So what we have here, I see that x can be written as -4, and that's it. So we can use substitution method to solve this equation, system of equations. So let's plug in -4 into the second equation. So 3 times -4 plus y squared equals 13. Y squared equals 13 minus plus 12. So y squared is equal to 25. So y is equal to plus minus 5. So when x is equal to -4, y equals to 5 or y equals to -5. So your answer must be written in the following form. So -4, 5. So this pair of x, y is the solution of the system of equations, or it would be -4 and -5. So your answer is C. Next, find x, y from the system of equations. X, y from the system of equations. So let's see what we can do. Well, I see that it almost looks like one of the short multiplication formula, the very, very famous one. So I see this, it lacks something. So let's add this, missing parts just to get, the full image of the short multiplication formula. So x squared plus 2xy plus y squared. Since I've written 2xy, I have to subtract xy from the left hand side to have exactly the same equation. You see, if to compare what I've written here with the very first equation of this system of equation, you'll see that these two are exactly the same things. I just changed the look of it. Now I'm gonna change it more. I'm gonna modify this to x plus y squared minus xy, that is equal to 37. Now I have x plus y given already. So x plus y would be 7 squared minus xy, 37. So 49 minus xy equals 37. So xy would be equal to, it's going to be equal to 12. That's it. So E is the correct answer. Next question. Question number 10. Find the sum x squared plus y squared plus z squared from the system of equations. So xy, where x times y equals 6, x times z equals 12, and y times z equals 8. Well, I have to find x squared. And I see that if I'm going to work with the first two equations, so basically if I'm going to multiply them, by multiply I mean multiplying left-hand sides and right-hand sides. On the left-hand side, I'm going to have x squared, right? But not only x squared, I'm going to have x squared. X times x would be x squared. I have it already. This is what my goal. But I'm going to have something redundant that I don't want to have. Y times z as well. So to get rid of it, I see that it would be very, very nice to divide by y times z. And luckily, we already have y times z given. So basically, I'm multiplying first two equations and divide by the third one. So we see that x squared would be equal to 6 times 12 divided by 8. And the final answer, if to divide by 4, it's going to be 3, and divide by 2, it's going to be 3. So x squared is equal to 9. Now, likewise, we can find y squared and z squared. So let's see what we can do about it. So I need to find again y squared. So I see y in the first equation and in the third equation. So I'm going to multiply these two. So what if to multiply first equation times the third equation, Again, what is redundant? X and Z product, and divide by X and Z, I'm going to have the following. So XY is 6, YZ is 8, divided by XZ 12. And it's going to give me, you see, if to simplify this left-hand side, we're going to have Y squared, that is equal to 4. All right. And again, we can find, using the same method, a Z squared. I see Z in the, let's see, in the second and in the third equation. So I'm going to multiply these two, X times Z times YZ. And again, I have Z squared, but I have X and X times Y product. That is redundant here. So I'm going to divide by X times Y. What I'm going to have, 6 XZ. XZ is 12 times YZ 8 divided by XY 6. That's it. It's going to be 16. So it's going to be X squared plus Y squared plus Z squared would be 29. That is the final answer. Next question. Motorboat travels downstream for 24 kilometers and upstream for 16 kilometers in total of 4 hours. If the river's flow speed is 2 kilometers per hour, find the speed of the boat in still water. Or basically find the speed of the boat. So again, we have information about speed, travel distance, and the time spent on it. So what we have, we don't have speed of the boat given, but we know speed of the current or the flow. So traveling downstream, so we have speed of the boat plus speed of the current if you travel downstream. And we have information that you travel downstream for 24 kilometers. And upstream, you traveled upstream for 16 kilometers. Speed of the boat minus 2. And you spend on the whole journey 4 hours. So say T1 and T2. T1 plus T2 equals 4 hours. All right, how to find T1 given the distance and the speed? So it's going to be 24 divided speed of the boat plus 2 plus T2 16 divided by speed of the boat minus 2. Again, guys, I'm using here very, very basic equation of the distance. S equals V times T, or D is equal to V times T. All right, equals 4. Now we have to solve this equation. Use substitution. I'm going to use this new variable x here. So basically 24 x plus 2 plus 16 x minus 2 equals 4. So let's solve this equation. So it's going to be 24 x minus 2 plus 16 x plus 2 times 4 x squared minus 4. So what we're going to have, 24x minus 48 plus 16x plus 32, 4x squared minus 16. What we have here, so let's simplify it. So we have 4x squared. So we have 24x and 16x. It's going to be 40. If to move this to the left-hand side, it's going to be negative 40x. Then we have negative 48 plus 32. It's going to be positive 16. I'm sorry, negative 16 and with negative 16. So basically we're going to simplify this all out. It's going to be canceled out. All right, so we're going to have equals 0. And now we have quadratic equation, incomplete quadratic equation. For this quadratic equation, we don't need to use discriminant formula. What we can do, we can factor out the common factor, which is This particular case, we can factor out 4x. We're going to have x minus 10 equals 0. Well, we could have just divided by 4 first. So basically 4x equals 0 and x is equal to 10. So we don't consider that, we consider that the boat was, moving. So we don't take the speed as 0. We take the speed as 10. So speed of the boat in still water is 10 kilometers per hour. Next question. Solve the equation x minus 3 that is equal to 8. Find the product of the roots. So x minus 3 equals absolute value, so modulus equation. So it's either would be 8 or negative 8. X minus 3 equals 8 or x minus 3 equals negative 8. So x would be equal to 11 and x would be equal to negative 5. Product of the roots would be negative 55. Solve the equation x minus 2 cubed minus x minus 2 times 13 minus 4x, that is equal to 4. You see here common factors, isn't it? It's as if you have t cubed minus t times 13 minus 4x. So when you have common factors, you can just take them out. So I'm going to take x minus 2 out of the brackets. And in new parentheses, I'm going to have x minus 2 squared minus 13 minus 4x left. Now I see the product that is equal to 0. So I don't need, again, to open the brackets and anything. I don't need to do anything like that. So I'm going to leave x minus 2 as it is. I'm going to open the brackets within the second parenthesis. I'm going to have x squared minus 2ab minus 4x plus 2 squared 4 minus 13 plus 4x. Guys, be careful with the parentheses. You see, when you open parentheses, you always have to pay attention. Equals to 0 to change or not to change the sign. In this case, in front of parentheses, we have negative sign. So basically, you multiplying each and every term in the parentheses by -1. Then we have x squared. So minus 4x, positive 4x canceling each other out. We have negative 9 equals 0. So x, or both of them are equal to 0. X minus 2 equals to 2. Or x squared minus 9 equals 0. X squared equals 9. X is equal to plus minus 3. So this equation is equal to 0 when x is equal to 2 or 3 or negative 3. Find the product of the roots. So we have product would be 2 times negative 3 times 3. So it's going to be negative 18. Next question, find x squared plus y squared from the system of equations. Write down your answer. Since I have x and minus y given, I'll express the sum of the squares as x minus y squared plus 2xy. We can multiply first equation by 3. Let's do this. Let's see what it's going to give us. So x minus y times 3 plus 9xy times 3. What is that? 42. Then we have 3x minus y minus 2xy equals 9. So I'm gonna subtract these two equations. I'm gonna have 11 xy. So it's gonna be, yes, correct, 33. So xy equals 3. That's it. We found xy. When xy is equal to 3, it's not difficult to find x minus y. So you can actually plug xy that is equal to 3 into either of these equations, into first or second equations. For me, it looks like the first equation is a bit easier to work with. So I'm gonna write x minus y plus 3 times 3 equals 14. x minus y equals 14 minus 9 would be 5. That's it. I know the difference. There's 5. I know the product. So basically I can find x squared plus y squared already. And it's going to be equal to x minus y squared plus 2xy. So it's going to be 5 squared minus, plus 2 times 3. 25 plus 6. And that is equal to 31. Next question. So we have a box containing a pair of shoes, weights 1600 grams. So we have a box. So we have mass of the box and we have 2 shoes. So let's say it's M shoes. M shoe. Well, we have mass of box plus mass of 2 shoes together is 1600 grams. When 1 shoe is removed, the remaining weight is 1050 grams. What is the weight of the box? So basically, 1 shoe is taken. We have mass of the box plus mass of 1 shoe left. That is equal to 10 and 50. That's it. We have system of equations that we can solve. Let's subtract both sides. So mass of the shoe would be 600 minus 550 grams. 550 grams. So what is the weight of the box? But this is not what we're looking for, so we have to find weight of the box. I'm going to use second equation again because I feel like it's easier to plug in the value there. So 550 equals 150. So mass of the box would be 1050 minus 550. And it's going to be just 500 grams. Question number 16. The average age of 20 athletes is 15 years. When a 34-year-old athlete leaves, find the average age of the remaining athletes. Let's say the age of the first athlete is x1. The age of the second athlete is x2. The age of the third athlete is x3. Of the 20th athlete is x20. So basically we have to sum up the ages of all 20 athletes like we did right here. And we have to divide it by the total number of athletes. In this particular case, it's 20. And we already have the information about the final result. And the average or mean age is 15. From this equation, we can find the sum of all ages of these athletes. So it's going to be 15 times 20 or 300. Now, when a 34-year-old athlete leaves, find the average age of the remaining athletes. So if one athlete leaves, we no longer have 20, but we have 19 athletes. So in denominator, we have to write 19. And if one of the athletes leaves, it means that the sum that we had earlier will be decreased by 34. And that's it. We know that this sum here is equal to 300. So it's going to be 300 minus 34 divided by 19. So 300 minus 30 is 270. 270 minus 4, it's going to be 266. Divided by 19. 266 divided by 19, so it's 1 and it would be 4. So the average age would be 14. Question number 17. A father is 29 years older than his son. 12 years ago, the father's age was 30 times that of his son's. How old is the father now? Well, to solve age problems, we usually create tables that represent the ages of different individuals in the present, past, and the future. For this particular problem, we have to create a table that would represent the age of a father and a son. We see that at the moment or in the present, you can write now, father is 29 years older than his son. So if his son is x years old, father would be x plus 29 years old. Now, then we have information about the past 12 years ago. So we have to add one more column that would represent the information about the ages in the past. Well, it's not a secret that age does change with time. So 12 years ago, if son is x years old now, 12 years ago he was x minus 12 years old. And father was x plus 29 minus 12. Or in other words, father was x plus 17 years old. We have no information about the future, so I'm not going to create yet another column for the future. So first you're creating those columns about their ages in the present, in the past, and in the future if we have information given. And only after you are applying given conditions. So it says that 12 years ago, so I'm looking at this past column, father's age. Father was basically 30 times older than his son. So it's going to be x plus 17 equals 30 times x minus 12. And then you can solve this equation for x. So let's open the brackets here. Let's multiply. We're going to have 360. Then we have 29x. And here we have 377. So x would be equal to 1 and 3. That's it. So how old is the father now? Well, it's not the final answer. We found how old is his son. So son is 13 years old. Then the father, whose age at the moment is x plus 29, would be 13 plus 29, or in other words, 42 years old. Find x plus y from the system of equations. Let's open the brackets in the first equation. Let's multiply x by y. So we're going to have xy minus 6x minus 6y plus 36 equals 10. In the next equation, we have x. We can factor out xy and have x plus y that is equal to 20. Then let's simplify the first equation further. We're going to have, well, let's leave the second equation as it is. Nothing can be done here. In the first equation, xy, we can factor out 6 and have x plus y plus 26, that's equal to 0. Well, now we have to solve this system of equations. We're going to be using substitution method. I can substitute x plus y. So x plus y equals 20 divided by xy. So what we're going to have, xy minus 6 times 20 over xy plus 26 divided by 0. Just for simplicity, I'm going to substitute xy with t. Just for the time being, we'll get back to all those substituted variables later. So it's going to be t minus 120 divided by t plus 26 equals 0. Or t squared plus 26t minus 120, that is equal to 0. So first t1 would be equal to So it's negative 26, so it's negative 30, and T2 is 4. Now, xy, so basically xy is equal to 4 and xy is equal to negative 30. When xy is equal to 4, we have to find sum, x plus y. So it's going to be 20 divided by xy, or 5. And then we have x plus y equals negative 20 divided by negative 30. The answer in this problem would be 5, just because they ask us to find, well, it hasn't been written here initially, to find positive value of the sum x plus y. So let's indicate it. So positive value of the sum. So that's why the final answer is 5. Question number 19. 2 brigades working together can build a house in 15 days. The first brigade can finish the task 16 days earlier than the second brigade. How many days would it take the first brigade to build a house on its own? Well, we have 2 brigades that can complete a task of building a house in 15 days working together. It takes okay, so the first brigade can finish the task 16 days earlier. So if it takes x days to finish the task for the first brigade, it will take x plus 16 days for the second brigade to finish the task working alone. How many days would it take the first brigade to build the house on its own? So basically, we have to find x. This is what we have to find. Now, any given work problem can be solved using a very, very basic formula. So, which is the following. So we have work equals rate times time. So here W of work represents total amount of work. R represents rate or amount of work done or completed. It would be better to say completed. Completed per unit of time. So amount of work completed in a day, per hour, and etc. And T represents time taken to complete the work. All right, once you have this formula written, you can apply this formula for any given work problem. In this particular problem, 2 brigades are working together to build a house, one particular house. So we have to build one house. It's amount of work. So it could have been written 300 houses, 500 houses, or it could have been written as well to complete a work. If amount of work is not given, we always take the total amount of work as 1. Because if they don't tell you how many houses you have to build, you assume that by completing the full work, you mean, so building 100 out of 100 houses, building 7 out of 7 houses, building 3 out of 3 houses. So 3 out of 3 or 3 over 3 equals 1. So, okay, you have to remember, if the total amount of work is not stated in the problem, you can take it as 1. But if it's stated like 300 units and etc., you're going to write 300 instead. All right, rate of change, and we see that we have two brigades working together, and if first brigade can complete or build a house in X days, in 1 day it's going to complete 1/x part of the house. If the second brigade can build this house in X plus 16 days, so if they work together, their rates are being added, so that's completely normal. So they're going to work faster together. And amount of time taken to complete the work, this is what is left. And we see that in the problem, the very beginning, it's been stated that to complete the work by working together, these two brigades need 15 days. So we're going to write 15 here. And that is it. Now we have to just solve this equation for x. We write this down as 1/x plus 1/x plus 16. That is equal to 1/15. Let's bring them to the common denominator. It's going to be x plus 16. We have x plus 16 plus x equals 1/15. Now cross multiplication. All right, it's going to be 2x plus 16. Maybe before cross multiplication, I can simplify it further. All right. Now, after cross multiplying, we're going to have x squared plus 16x equals, all right, 13x plus 240. All right, x squared plus 16x minus 30x minus 240 equals 0. X squared minus 14x minus 240 equals 0. X equals x1 equals, so it's positive sum of two numbers, that is positive 14, and the product is 240, negative 240, so it's going to be 24 and negative 10. So our answer is 24, which means that the first brigade can build a house in 24 days working alone. Question number 20. Find the value of the expression given that x1 and x2 are the roots of the equation. Using the Vieta theorem, we see that x1 plus x2 is equal to 15, and x1 times x2 is equal to 25. Now we have to find the value of the expression square root of x1 plus square root of x2 times x1 times x2. So even though we have the product x1 and x2 given, we don't have the sum of the square roots of the roots of this equation. Square root of x1 plus square root of x2 can be written under the square root as x1, square root of x1 plus square root of x2, the whole thing squared, times x1, x2. As you can see, I haven't changed anything. I just changed the look of it. And then I'm going to raise square root of x1 plus square root of x2 to the second power. I'm going to have x1 plus 2 under the square root x1, x2 plus x2 times x1, x2. Now I have everything to find the value of this expression. I have the sum x1 plus x2 given, and I have the product of the roots. So it's going to be 15 plus 2 times 25 times 25. So what we have here, 15 plus 10, it's going to be 25, square root of 25 times 25, it's going to be 5 times 25, it's going to be 125. Next question. A 20-cent coin, Azerbaijani currency, weighs 6.6 grams, 6.6 grams, and 50-cent coin weighs 7.7 grams. If the total weight of 10 manat in 20-cent and 50-cent coins is 189.2 grams, how many 50-cent coins are there? So I don't know how many 50-cent and 20-cent coins I have here. Let's say I have X 50-cent coins and Y 20-cent coins. I don't know how many 50-cent coins and 20-cent coins I have, but I know that if to add up all these coins money-wise, I'm gonna have 1,000 coins. So basically, I can create two equations for the weight and for the total amount of money in terms of the numbers of 50-cent and 20-cent coins. So I have 7.7x plus 6.6y equals 189.2, and I have 50-cent coins, 50 times x plus 20 times y equals 1,000. 1,000. Now I have to solve this equation and find how many 50-cent coins are there. So basically I have to find x. Well, to solve this system of equations, we can multiply first equation by 10 and then divide by 11. Divide by 11. So eventually we're gonna have, well, let's multiply by 10 first. Let's do it step by step. Hopefully we'll have time. We'll have space left. 77x plus 66y equals 1892. And then second equation can be right away divided by 10. So I'm gonna have 5x plus 2y equals 100. Then I can divide the first equation by 11. I'm gonna have, so if to divide the first equation by 11, we're gonna have 7x plus 6y equals 172. 5x plus 2y equals 100. And that's it. We have to find x from the system of equations. I can multiply the second equation by 3 and then subtract. So I'm going to have 7x plus 6y equals 172. I'm going to have 15x plus 6y equals 300. 8x, that is equal to 128. X would be equal to 16. So we have 16 50-cent coins. Question number 22. Teams A and B plan to travel 2 different distances. So we have team A and team B. Let's say team A plans to travel X kilometers, while team B plans to travel Y kilometers. On the first day, they covered 30 and 40% of their respective routes. So, on the first day, Team A travels 30% of their respective routes. So basically, it travels 0.3x, while Team B travels 40% of their respective routes. So it's going to be 0.4y kilometers. On the second day, they traveled 10% and 30% of their remaining distances. So if they traveled 0.3x, remaining distance would be 0.7x, and 10% of it we have to just multiply it by 0.1. While the second team traveled 30% of their remaining distance. If on the first day they traveled 0.4 y kilometers of distance, the remaining distance is 0.6y, and then they're traveling on the second day 30% of it, so we multiply by 0.3. So on the second day, Team A travels 0.07x kilometers, while Team B travels 0.18 y kilometers. Okay. Then, if the distance Team A covered on the first day is 3 times the distance covered by Team B on the first day, what percentage of Team B's remaining distance is Team A's remaining distance? So basically, if 0.3x is 3 times the distance covered by the Team A on the first day, so basically 3 times 0.4y, find what percentage of Team B's remaining distance is Team A's remaining distance. So percentage of, so we have Team B remaining distance, Team A remaining distance, all right, in percentages. This is what we have to find. Well, the remaining route or remaining distance for Team A would be, so if they traveled, so the total, if total route is x and they traveled during these first 2 days 0.37 37x kilometers, the remaining distance is 0.63x kilometers. That is the remaining distance of Team A. So here we're gonna have 0.63. Then here, if the total distance is y and during these 2 days they traveled 0.58 y kilometers, the remaining distance is 0.42 y kilometers. All right, so let's go back to the question. We have to find this percentage of the, so TA remaining distance by Team A would be 0.63 x divided by 0.42 y times 100. Now guys, we have to use the very first equation written a bit earlier here. This equation will help us to see what is the relationship between x and y. So if to simplify it, by simplifying, we can multiply both sides by 100 first. So we're gonna have 3x times 12y, or x equals 4y. And that's it. We can substitute 4y instead of x in this ratio. So 0.63 times 4y divided by 0.42 times y times 100. We can simplify, so we can cancel out the y's. We can divide, multiply by 100, so 63 over 42, I have no space here, so eventually I can divide by 7. We're gonna have 600%. Question number 23. In each of the 3 figures, an equilateral triangle, a square, and a circle are placed on top of one another to form 3 different shapes. The heights of the figures are 25, 23, and 22 centimeters respectively. So the heights of all these figures placed on top of each other are 25, 23 and 22 centimeters. Let's say the height of this square is x, height of this, or basically diameter of this circle is y. Then height of this triangle is z. And again, since we have the same square, the height of it would be still x. Again, yet triangle, so it's going to be z, and the diameter, let's say y. Given this information, we have y plus x is equal to 25. we have x plus z that is equal to 23, and we have y plus z that is equal to 22. If to add left hand side and right hand side of these three equations, we're going to have 2x plus 2y plus 2z on the left hand side, and on the right hand side we're going to have 70. So x plus y plus z is equal to 35. Since we need to find diagonal, the length of the diagonal of the square, it would be better first to find the side, the length of the side of the square. All right, so we basically have to find x first. Well, to find x, you have to know the value of the sum y plus z, and it's already given in the equation, in the third equation. So x plus 22 equals 35, hence x would be equal to 13. Hence, the side of the square is equal to 13, and to find diagonal, we can use Pythagoras theorem. So diagonal squared is equal to 2x squared, or diagonal is equal to 13 root 2. Next question. 62 students attend football and volleyball practice. 13 students attend both activities. If the number of students in the football group is twice that of the volleyball group, how many students participate in football practice? So let's start off with we're going to be using Euler-Venn diagram. I started with universal set that has information about students attending football and volleyball practices. 13 students attend both, so we have 13 right here. If the number of students in the volleyball group, so I don't know how many students I have in the volleyball group. Let's say here we have y students, here we have x students, and it says if the number of students in the football group is twice, so x plus 3, it's the number of students in the football group is twice that of the volleyball, two times the number of students in the volleyball group, which is 13 plus y. How many students participate in football practice? So basically we have to find x plus 13. We have to find the number of students that participate in football practices. So let's solve this equation. We're gonna have x plus 13 equals 26 plus 2y. So we have x minus 2y equals 13. On the other hand, see that x plus 13 plus y equals 62. It's the number of students participating in either football or volleyball practices, or both of them. So it's going to be x plus y equals 62 minus 13. It's going to be 49. So x plus y would be equal to 49. Now we have two equations to work with. So we're going to have x minus 2y equals 13 and x plus y equals 49. Let's see what they ask us to find. How many students participate in football practice? So, well, since we're looking for football practice participants, it would be enough to find just x. All right. Okay, let's first find y because it's easier right away and we don't need to multiply by anything here. So if to find the difference of these two equations, we're going to have minus 3y and negative 36. So y would be equal to 12. So we have 12 students who participate only in volleyball practices. So y would be equal, if y is equal to 12, it's not difficult to find number of people attending only football practices. So we're going to have x plus 12 equals 49, and x would be equal to What is that? 737. That is x. But the question is about number of people attending football practices. So which is x plus 13. So it's gonna be 37 plus 13, or we have 50 people. Next question. The question number 25. If -1 is one of the roots of this given equation, find the product of the values of the parameter a. So since we have information about this equation on being quadratic, k must be equal to 2. So we're going to have x squared minus x plus 2a squared minus 9a plus 1 equals 0. And we also have information that x is equal to -1 is the root. I can plug in -1 instead of x and get 0 at the end. So -1 squared minus 1 plus 2a squared plus 9a plus 1 equals 0. So it's going to be 1 minus 1, 1 plus 1. We're going to have 2 here, so 2a squared plus 9a plus 3 equals to 0. And product of the values of the parameter a, using the Vieta theorem, we see that the product of the values of parameter a would be 3 over a, or 1.5.